Good morning, everyone. I'm Shweta Singh, and I welcome all of you to Q&A session. How are you all doing? Am I audible? Am I audible? Okay,
Yes, sir.
fine, fine. Thank you. So, we were discussing about the matter in our surrounding, and still we are discussing the matter in our surroundings. Fine, but we are specifically discussing here states of matter. We already discussed about the solid state, we discussed about liquid state, and now we will be discussing about the gaseous state. That's the topic of the day. Okay, so let's start here. For this topic, we should know few things, like we should know about pressure. Do you have the idea what is pressure? Do you know what is pressure? Anyone who can tell what is pressure? Anyone?
Exerted force by a particular unit of area.
Okay, so pressure is basically force applied per unit area, right? A force applied per unit area, that is actually pressure. So if I have to write its formula, just give me a second. Yeah. So if I have to write its formula, I'll be saying that pressure is equal to force upon area. So per unit area, how much force is applied, that is pressure. Do remember this. Okay, because we are talking about the gas, so we need to know about the pressure also. Okay, fine. So let's move ahead now. The states of matter in which we are studying different states of matter, that is itself carrying 1 to 3 marks. Okay, so we will discuss about the properties of gaseous state, and after that we will also discuss something which is out of syllabus, gas laws. Okay, this part is out of syllabus, but we will be doing because it is related to gas. Okay, so let's start with this. Gaseous state, this is what we need to discuss. So the same way as we discussed about the liquid and solid, the same way we will be discussing about the gases also. So the gaseous particles, they are far apart from each other, they have large space between the particles. So spaces are the highest in case of gases, interparticle spaces. Forces of attraction, interparticle forces of attraction, that will be least in case of gases. That's why they are so far apart from each other and they have large spaces between them. Why? Because the forces of attraction, that is weaker. Okay, then the third one, kinetic energy is highest, because forces are weakest, have large spaces to move. So the kinetic energy of the particles is highest in case of gaseous state. So on the basis of the properties of particles, what we discussed here just now, we were discussing about the properties of particles, right, present in gases. We were discussing about them. On that basis, coming to the properties of gases, they don't have definite shape, they don't have volume, definite volume. Okay, so as in case of solids, they had fixed shape and fixed volume. Liquids, no fixed shape, but yes, fixed volume. But gases don't have either. Okay, they don't have either definite shape or definite volume. So they don't have definite shape or volume. Okay, so this is something that we discussed before also, like when the food is being cooked in your kitchen, how do you get smell in your room? So why? Because of the diffusion of particles. So the particles of the gases, they flow, they move. So basically, gases show the property of fluidity. Which other state shows fluidity? Which other state shows fluidity?
Liquid.
Liquid. Solid is not fluid in nature, but gases and liquid, they both are fluid. Okay. And why do they show? Because they are continuously moving. Gases move very fast and can be stopped by the solid walls of containers, right? Okay. Gases can be easily compressed. Basically, the gases are compressible. The only state which is compressible is the gas, right? Liquid and solid both are incompressible, but gases are compressible. We can accommodate them in very less volume, right? Okay. Then, like, what about that soda bottle? You know that carbonated drinks. Fine. When we open them, so much fizzles come out. Why? Because carbon dioxide comes out of it. So basically, what happens, like, if we have a cold drink bottle, right? If we have a cold drink bottle, fine, in which the CO2 was present. Now, how was it present? It was present in high concentration, like in the water, lot of CO2 was, pushed inside. How? By creating the pressure. So why? Because gases are compressible, so we can accommodate lot of carbon dioxide in this bottle. But once we open it, the pressure is released and the gases starts coming out immediately, so we get frizzles of the uh, carbon dioxide. But this is the example where we can say, yes, the gases are compressible. That's why we were able to put a lot of CO2 in that bottle. Okay, fine. After this, these are the properties. I hope you are writing all these properties. So have you written the gases? They don't have fixed shape or volume. They
Yes,
have
sir.
the property of fluidity. They move very, so don't have to write move very fast, but you should write they are compressible. Okay, so you have written already. Fine. Do remember, solid, liquid, gases, they all can diffuse. Okay, they all can diffuse. Do remember this. So solids, liquids, and gases, they can diffuse in liquids, right? But the rate of diffusion of liquid will be higher. Why? Because kinetic energy of the particles in liquid, that is more than the solid. Fine. So that's why the rate of diffusion is higher in case of liquid. And the reason is given below here. Why is it so? Because in liquid state, particles move freely and have greater space between them. Fine. So in short, you can simply say that the kinetic energy is higher in case of liquid particles as compared to solid. Okay, so let's compare now solid, liquid, and gases. Let's compare them. First, we will compare their shape. So what shall I write for solid? Is it fixed or not? Fixed or not? Fixed. Okay. Liquid? Liquid?
As fixed.
Not fixed. Gases?
Not fixed.
Not fixed. Right? So we have fixed shape only in case of solid, and liquid takes the shape of the container. You can simply say liquid takes the shape of the container. Volume, solid,
Fixed.
fixed. Liquid,
Not fixed.
fixed. Gas,
Not fixed.
Fixed.
Not fixed. So volume is fixed or definite in case of solid and liquid, but it's not fixed in case of gas. Okay. Next, interparticle forces of attraction. Solid,
Strong.
strongest. Okay. Gas.
Weakest.
Yes, weakest, and liquid moderate. So very strong in case of solid, moderate in case of liquid, and it's weak, very weak in case of gas. Okay, next one, interparticle spaces. Interparticle spaces. Okay, so smallest, right? And in case of gas, they have large spaces. So we can simply say in case of solid, very less interparticle space. In case of liquid, moderate. And in gas, we have very large interparticle space. So please note down, make a table, note down these points. We will follow up with more points. First, note down all these points. Done? All of you? Okay, then. Fine. Next one, fluidity. Fluidity. What shall I say about solid?
No fluidity.
Right. It can't flow. Right. Liquid.
Both liquid and gas have fluidity.
Yeah. Liquid and gas both can flow easily. They can flow easily. So solid cannot flow, whereas liquid and gas, they can flow very easily. Both of them can flow very easily. Okay. Compressibility.
And
Not
Compressibility.
compressible.
solids are mostly
Not compressible.
non-compressibility. Liquid is easier
Liquid are
than solid, but
compressible.
is easier than solid, but like not most compressible, and while gas is the most compressible.
Basically, like solid and liquid both are incompressible. You cannot compress them, whereas gases can be compressed easily. The gases are compressible. Okay, so solid incompressible, even liquid incompressible, whereas gas compressible. Okay, so not instead of writing not compressible, you can write incompressible. Okay, then coming to ability to fill the container. Ability to fill the container. No, solid has the fixed volume, so it cannot fill the container. Not even liquid, but gas can fill the container, right? So solid does not fill the container, liquid does not fill the container, but gas can easily fill the container. Why? Because solid and liquid, they have fixed volume, but gases, they don't have fixed volume, so they will occupy all the space present in the container. Okay. Density. What is the formula of density? What is density? Anyone? What is density? Yes, density is mass per unit volume, means in given volume, how much mass is present for a substance, right? So, density, what about solid, liquid, and gas? What do you say about density of them?
Then we have to tell density of solid, liquid. Yes.
Yes, you have to compare. Yes, Anay. Density means mass per unit volume, right? So density
Density
is
of liquid is P equals to M by V.
mass over volume. Okay, mass over volume. So means if I take this much volume, fine. So how much mass? So basically it is telling how much amount of matter is present in it, right? So how much mass is present in the given volume, that is density. Understood? Like if I take 1 meter cube of volume or 1 centimeter cube of volume, then how much mass is there? Okay. So yes, in case of solid, the density is very high because particles are closely packed. So density will be high. In case of gas, that will be very low, whereas liquid is going to have moderate density. Am I clear? Is it clear, everyone? Density, please note down all the points. Okay, so if you have noted
I
down, let's
noted.
move ahead. Yeah, okay, fine. Do it.
Man, noted.
Fine. So now we will move forward to the gas law. So I think this is easy thing about the gas, liquid, and solid. We have already discussed too much about them. Let's move on to the gas laws. Now these are the laws which actually tells you how does a gas behave when you change their some physical quantity like pressure. If you change the volume, or if you change the temperature, how is a gas going to behave? That behavior is actually explained by the gas laws. So what are gas laws? The relationships which describe the general behavior of gases are called gas laws. Okay, one thing, this is out of syllabus. I'm again telling you, this is out of syllabus. Okay, so a gas which obeys these laws is called ideal gas, means perfect gas, ideal. And always remember, there is nothing called ideal. There is nothing in the nature which is ideal. There will be some imperfection. Fine. So, what is an ideal gas which obeys all these gas laws? One thing more, these laws are applicable only to gases which does not undergo change. Like, you know what? If you have NO2, okay, suppose I'm having NO2 and I decrease the temperature, it will become N2O4. So this should not happen. It should not undergo any chemical change by changing the physical quantity like temperature or pressure. It should not happen. So this law won't be applicable. So there should not be any chemical change going on when the temperature is varied. Am I clear? Fine. So note down these points. Then we will see one by one all the gas laws.
Yes, sir. Ma'am, this is out of syllabus.
Yes, yes. Whatever we are doing now, those all are out of syllabus. Okay. So let's move on to the first law now. Boyle's law. So we are doing the gas laws. So first is Boyle's law. Now in Boyle's law, do remember we fix the temperature. We keep the temperature constant. First thing, right? And we fix the amount of gas, right? We also fix the amount of gas. How much we have taken, we fix the amount of gas. And we fix the amount of gas. I mean, in what terms do we express the amount of gas? We don't express it in terms of mass, or we don't express it in terms of volume. We say number of moles. Do you know what is mole? Do you have the idea what is mole? Anyone? No? Okay, so I'm not going into detail of mole here, but let me tell you in simple words, like mole is actually going to tell you number of particles. When we are talking about the microscopic particles like atoms, molecules, ions, all these electrons, protons, so their numbers, the numbers of particles are actually expressed in terms of mole. Okay, the way we have 1 dozen equal to how many number? 1 dozen equal to 12, right? 1 score is equal to 20. Fine. Similarly, we have 1 ream equal to 500. In similar manner, 1 mole is actually equal to 6.022 into 10 raised to power 23. These many particles make 1 mole. So because we are talking about the microscopic particles, very small particles, that's why this number is so huge. The amount of 1 mole is so huge. Am I clear now what is 1 mole? right? So like it's something which should be taught in very detail, but right now just to understand, when I'm using the word mole, that means number of particles. Okay, so we take the fixed amount of gas at constant temperature, and when we increase the volume, when we increase the pressure, volume decreases. On increasing the pressure, volume decreases. And this is very common, right? Which is very logically correct, that when you increase the pressure, the volume will decrease. So we say that the pressure of fixed amount of gas is inversely proportional to the volume of gas, but you have to keep the temperature constant. Fine. Let's understand in this manner now. Just give me a second. Yeah. Suppose I have a container, okay, and a gas is there, and I'm saying its volume is V, right? And right now, the atmospheric pressure is applied on it. So I'm saying the pressure is P. Now, what have I done? I have taken a piston and increased the pressure to 2P. I've doubled the pressure by by moving the piston down, so when I will move down the piston, so that the pressure becomes 2P, now what will happen? The gas will be compressed and the volume will become half. Now once you made the pressure double, the volume of the gas will become half. Am I clear? Am I clear with this example? Okay, so this is what I'm saying, that pressure is inversely proportional to volume. Means if you increase the pressure, volume will decrease. Okay, so we write it like this. Do you know this sign? If I write it like this, I don't know, in ninth class, do you know this thing, that P is inversely proportional to volume? Do you have this idea that we write it like this?
Yes, ma'am.
Yes,
Okay,
ma'am.
no problem, Ane. See, so whenever I have to show no that something is inversely proportional, right, Ane? So inversely proportional means the same thing, that when you increase something, other thing is decreasing. So like the pressure and volume, they are inversely proportional. When you increase the pressure, volume will decrease. So this is written like this, that P is proportional to 1 by V. Okay. Good, Anne. Fine. So now when I remove the sign of, like when I remove this sign, I have to put some constant there, right? When we remove this, you will study all these things. It's okay, Anne. I know it's class 9, so it is very obvious that you might not be knowing it, right? But yes, we have to work little harder towards our goal. Fine. So when we have to remove the sign, no, I have to put some constant. So I'm going to put a constant here. P is equal to K1. This is my constant. Right? This is my constant into 1 by V. So it will finally become PV is equal to constant. Right? So rather I write it on the left hand side. So better you will be able to link it. So P is equal to K1 1 by V. So PV is equal to K1, and K1 is nothing but the constant. So PV is going to be constant. P into V, the product, pressure into volume product will be constant. But do remember, this is only possible when the temperature is fixed for the fixed amount of gas. Now temperature is shown here with T. Okay, and amount of gas is in terms of moles. So N represents moles of gas. Am I clear? Have you understood so far? I know this is going little bit above your level, but I think this much you can understand. I can, I'm trying my best to make it as simple as possible, but you should know about these laws little bit. Okay, fine. Okay, so let's move ahead. So I think everybody understood this. What is Boyle's law? In Boyle's law, you keep the temperature constant for the fixed amount of gas, and you find that pressure is inversely proportional to volume. Please note down. Okay, so done. I can move to the next law now. That is Charles' law. So Charles is the name, right? So you don't have to write after E, that, right? So Charles' law. Charles' law states that if I keep the pressure constant, now in Charles' law, pressure is constant. Okay, pressure is constant. And for the fixed amount of gas, again, we will take in number of moles, right? So the volume of fixed amount of gas is proportional to its temperature. Means it is directly proportional to its temperature. What does it mean? For fixed pressure, right? For the fixed pressure, if you increase the temperature, volume will increase. But it is only possible when you fix the pressure. You are not changing the pressure. Okay, so if you increase the temperature, volume will increase. Now, how is it? Look at here. If I have a container here having this much volume, okay, gas is here, right? And how does gas exert pressure? How does gas exert pressure? This is one of the question in your exam also. This is not out of syllabus. How does gas exert pressure? Can anybody explain? Hmm? Important question. I'll rewrite the question. Sorry. Okay, so what happens when the gas molecules move around? They move randomly, isn't it? These gas particles are there, molecules are there, they move here and there randomly because they have high kinetic energy. Fine. So they will be colliding with each other as well as they will be colliding with the walls of the container, right? They will be colliding with each other and with the walls of the container also. They will be hitting the walls of the container. Now, when they hit the container, what happens? They apply force on them, right? They apply force on the wall. So force per unit area, the force applied by the molecules per unit area, that is called pressure. From there, the pressure arises. Am I clear? Am I clear, Rudra? So, yes, you're absolutely right. So, when you have to write, you have to mention few keywords there. So, what are those keywords? Let's write down. We said the gas molecules have high kinetic energy, right? So, they move randomly. Fine. When they move randomly, they collide with each other and also with the walls of container, right? So when they hit walls of container, so what happens? They apply force on the walls. So force applied per unit area.
Ma'am,
So
they are in the
that,
constant randomly motion.
yes, they are moving constant. You know that they are the particles continuously move. That's the nature of the particles of matter. They are continuously moving. And in case of gases, they have high kinetic energy. So they are moving here and there. No, nothing is there to stop them.
Yes, ma'am.
Okay. So this is important question for your exam. This is not something out of syllabus. So these are the keywords which you have to put in your mind. Then only your answer will be completed. Okay. So note down if you want to. Then I'll again come to the Charles law. I hope writing is clear to you.
Yes, ma'am.
So you will write, see, I have only given you the key terms. So you have to write full answer like the molecules present in gas, they have high kinetic energy and they move randomly. When they move, they collide with each other as well as with the walls of the container. And when they hit the walls of container, they apply force on the walls. So the force applied per unit area, that is pressure. Done?